Hi, Curt Schwaderer here with Open Systems Media, talking with Microchip's Greg Robinson about what's new with 8-bit microcontrollers and what you're announcing here at the show. Hi, Greg.
Hi, Curt.
So tell us a little bit about the PIC16, its origins, and its historical applications.
Sure. So we're announcing a family of 11 products today, ranging from 14 pins up to 44 pins, and a variety of different memory cuts. This family came from another family that we had released a couple years ago that had what we introduced our new core independent peripherals with, and had a fairly generic analog peripheral set. And when we went out and talked to customers, what we saw was a lot of analog that was being wrapped around the products that we had released earlier. And a light bulb went off and said, you know, we should be integrating these into the products that we're releasing today. So with that, we introduced this new product. It has two operational amplifiers on there. It has a new module for our zero cross detect. It has a couple high-speed comparators on board, as well as our 10-bit ADD. And in addition to that, we also put an 8 and a 5-bit DAC on board. So a lot of analog integration.
Okay. In terms of the digital logic that pre-existed on the chip itself, can you talk a little bit about the peripherals there? You mentioned a configurable logic cell. Can you talk a little bit about what that does?
Certainly. So we have what we call our core independent peripherals. And these are peripherals that operate without the usage of the core. The configurable logic cell is one of the first ones that we came out with. And this cell can be configured as any of the Boolean logic functions, either an AND gate, an OR gate, an XOR gate. In addition, it also can be configured as a flip-flop, an SR flip-flop, a D flip-flop, or a JK flip-flop. And the power of these modules are, they can be used as single units, or they can be cascaded together to create a state machine. Okay. And then again, this is independent of the core.
Right, okay, so this is within an 8-bit microprocessor here. There's quite a complex bunch of analog and digital peripherals on this chip now.
Right.
Okay. Can you give us an example of what might utilize the entire portfolio or the breadth of this new PIC16 family that you're introducing?
Sure. So we've done a reference design that is an inductive cooktop. Okay. That is traditionally in the market with today, and we have taken that and we've taken a look at what's on the board today and redesigned that board to save our customers both cost and board space with the integrated peripherals that we put on this device.
Okay, interesting. I'd like to, can we go out and take a look at it, and you
Absolutely.
can kind of give us a tour of the actual live
application. Let's take a look at the board.
All right, great. Curt Schwaderer with Open Systems Media here at the Microchip exhibit booth, where we're going to see a real live example of the 8-bit MCU with integrated analog and digital peripherals and what it means to a real live embedded application. Greg, you want to tell us about it?
Thanks, Curt. So yeah, this is our inductive cook reference design. And if you see flip it over the back, we have the PCB here, and we're driving the inductive coil here. We have a feedback loop back here for current that we're sensing within the microcontroller. We're also looking for zero cross with our two comparators on the coils here. We're doing over voltage, over current functionality with the integrated ADD as well. And we're also using a zero cross detect in this application for a little different, non-traditional purpose for zero cross. A typical zero cross drives a triac or a relay. In this particular application, we're actually using it as a real-time clock. Okay. So we're taking the 60 hertz in, driving it into a counter, and then going off and doing some safety critical type of applications.
Okay, neat.
So here's the board here. If you take a look at the PIC microcontroller, which is right here, you'll notice there's no analog around it. And we've reduced the component count by 30%. And we estimate the overall BOM by $1.
Wow.
So we've reduced the customer's overall board size, and we've reduced the overall customer's cost of producing the device itself, or the board itself.
Interesting. So increased level of integration, lower cost. Sounds like a big advance in the market for an 8-bit microcontroller.
Absolutely.
Well, great. Appreciate your time, Greg.
Thank you, Curt.
Great to hear from Microchip and what you're doing with 8-bit technology and integrating peripherals with analog and digital components, saving cost, and the 8-bit microcontroller is alive and well here at Microchip. Thanks.